In today's lecture, we'll discuss functions in detail. So let's start. In this chapter, we'll study Python functions, types of functions, its advantages, what are user-defined functions, how to declare them, how to define them, how to use them. We'll study them in detail, this one. And then Python anonymous functions, pass by value versus pass by reference, and then recursion. So we'll discuss all these topics in detail in this chapter. So let's start. First of all, we should know about what is a function. If we talk about its definition, it is a self-contained group of statements which are intended to perform a specific task. Suppose if I want to compute addition of two numbers, multiplication, then division, multiplication, if I want to perform arithmetic operations and I want to develop a calculator for that, then for every arithmetic operation such as sum, subtract, multiply, divide, I can create different functions rather than computing them in a single program. So this is the basic role of functions, to divide a complete problem into small parts or small modules. As we can see, a calculator program can be divided into different parts in order to solve a particular problem. So that is why there are various advantages of functions also, which are as follows. First one is avoids repetition. So when we know that a particular statements are going to execute again and again, then we can use, or we should prefer, functions. Suppose I'm going to compute factorial. Suppose I want to compute this series up to n, so on up to n. Then you can see that we need to compute factorial again and again. So one way is to write the logic or put it in a loop, and then we can compute factorial. Another way is to make a function of factorial and then just pass the argument with this number. First time it will be 1, second time it will be 2, then 3, and so on up to n. That function will compute the factorial and return the result, and it will put over here, and then it will compute the entire series. That means we'll develop factorial program in the form of function only once, and it will be used by any number of programs. So this is one of the main advantage of functions, which avoids repetition. We don't need to compute that same code or you don't need to write same statements again and again. Just put them inside a function and they can be used later on as per need. Suppose if I have another series like this to compute factorial of all the numbers, then even then that factorial function can be called. Fine. So you need to create factorial function only once, and it will be called multiple times rather than creating it again and again. Another advantage is modularization. That means a large program is decomposed into smaller modules to make the program faster and easier, because it is easier to understand a small block of code rather than writing the same statements again and again in the program and writing large programs. So I already told you, while developing a calculator, you can divide each operation into different modules. Suppose I'm going to design a calculator. Then if it is scientific one also, then I can divide each operation into different modules in order to compute the result. Sine, cos, tan, log, And similarly, other functions which are arithmetic, which is add, subtract, multiply, divide, and so on. You can see that there can be any number of branches of a program by dividing them into different modules. So this is called modularization. Next is reduce size. The size of the source program can be reduced considerably by using functions appropriately in the program. So you can see that if we make modules of these all functions, and the main program will be reduced because we will just make a call to these functions and we are not going to write the main code, their code again and again. That means the size of the main program will be reduced. Next is logical precision. The use of user-defined functions allows a large program to be broken into smaller self-contained blocks or components, which is intended to perform a specific and unique function. Therefore, by the use of functions, the program becomes easier to code and debug. So I already told you, in order to identify any error in that particular block, it is easy as compared to finding the error in the large programs. Suppose there is some error in the subtraction module, I will just check it rather than checking the entire program. So logical precision is there. Precision means more accuracy. We can go more towards the accuracy, is called precision. Next is save memory requirement. It means different set of data can be transferred to the function each time when it is called. The use of functions saves huge memory space by allowing same set of statements to be used for different set of data. We know that for a function, different data sets are used. Suppose I have created a function sum with two data members, A and B, then the value of A will be changed or can be changed in every call, but the logic will remain the same. So that means it saves huge memory space because we are writing statements only once and using them numerous times. So it also saves memory space. Next is portable. Functions can be used in many programs, which encourages portability. So if you create module of function, module means package, you can also refer to them as package or header file that we study in C and C++. If you create header file of the functions, then by importing that header file or package, you can use the functions again and again in your program, and that means your program is now portable. So functions support portability. This is very important concept. We will also learn how to create packages, modules in Python, as we studied in C also, how to create a header file, and then we can use functions which are defined under it in a very easy manner. So these are various advantages of functions that we have studied. The first one is avoid repetition, modularization, reduce size, logical precision, save memory requirement, and portability, portable. Now there are various types of functions. You have already studied various types of functions which are categorized into two parts. One is called built-in functions and other one is called user-defined functions. Built-in functions which are provided by the Python, which are already built, which are already in its interpreter, or you can access them on command prompt, or you can use them in the script mode directly. And those functions are called built-in functions. The functions that we have studied in math package, in random number package, those functions you can use directly, that we have already studied also. So these are called built-in functions. Sine, cos, tan, log, these are built-in functions. Apart from that, you print the output with print, you take the input with input, you can typecast using data types like int, right, list, tuple. So all of these are built-in functions or methods that you can use directly. Other thing is called user-defined functions. User-defined functions means the functions that the user defines. That means the programmer defines according to his need. Those functions are called user-defined functions. The main focus of this chapter is to learn how to create user-defined functions. So we'll study user-defined functions in detail, and we'll just go through the list of built-in functions for easy reference. Built-in functions. The functions are already provided by the Python are called built-in functions. The programmer can use built-in functions readily without any additional effort to code the function. The functions which we have already used in previous chapters, such as print, absolute, random, range, print, input, eval, etc., are built-in functions. So here is a list of all built-in functions. You can go through them, and the description is also given along with them. So built-in functions are used according to our need, and we can readily use them. We have already studied many of them, and list methods, tuple methods, set functions methods, we have studied many of them already. So this is entire list of built-in functions available in Python. This is the complete list. So our main focus is to study user-defined functions. So we'll discuss this in detail. Python user-defined functions. So user-defined functions basically categorized into two parts in Python. One is called function definition and other is called function call. In C or C++, there is function declaration part is there, or we also refer to it as function prototype, which was required in C, C++, and Java. Because declaration is very important in C, C++. Before using any variable, any function, you need to declare them in C, C++, Java. But in Python, we use them directly. Therefore, this portion, that is function declaration or function prototype, is skipped over here. It is not in Python because we just write the variable name or assign value to it and use it directly. They are readily available for use. Similarly, the functions are also readily available for use once you define them. Therefore, there is no need to declare or mention the prototype of a function in Python. So you need to remember this. So what is function definition? It contains the actual code for the operation to be performed. Therefore, that means you need to write the actual code for what it is intended to perform a specific operation. It is mentioned in function definition. And function call, where the call to the function definition is made to perform a specific operation. So you will understand these two methods of declaring, of defining and calling function in the following section. I'll tell you how to do this in Python. So this is the syntax for defining a function in Python. It is very simple as compared to C. First of all, you need to write the keyword def, and then you mention function name, and then in parentheses, list of parameters is given separated by commas. So as we have studied in loops also, you need to put colon here in order to start the block of the function definition. So we'll write def, function name, then list of parameters, and then colon. So this is the way of defining a function. After colon, you will put indentation, and then you'll start writing the statements under that function. So docstring, that means you can write, it's like a comment, it is given in double quotes. This is a comment which is referring what is this function doing. The main purpose of the function is mentioned over here. And then in statements, you write the actual code of the function which is it is going to perform. And at last, you can write the return statement with the parameter or argument which is going to take the result back to the function call. So this is a syntax of function definition. First of all, you need to write function def function name, then list of parameters, colon, and then by putting the indentation, you have to write docstring statements and then return statement. So this indentation is very important over here, as we have studied in loops and if else also. So this is very important. Docstring is optional. It is not necessary to mention what is this function going to perform. This is for your reference so that later on you can check what is your program or a particular function is performing. So this complete explanation is given in these points. Next is function call. What is function call? Let's understand through a program, a simple program. First of all, we need to define the function. We'll write def, and then we have created a function with name print message, and in the arguments I have given a single argument which is str, that is string, and then colon. And in the doc string I'm writing this function prints the value of string passed as a parameter. So this is a comment. You can refer to it as a comment. And then print string return, because it is not taking any result with it. That's why we have just mentioned return. No need to specify any parameter within that. Print str, it will print the string message. Now how to pass function? This is done in function call. Function call of print message, and this function is passed. This argument is passed. Print message is a user defined function. So whenever this call occurs, the control goes to the function definition. And over here, it will print message str. So print str will display the message. Print message is a user defined function. And by the return statement, it will come back to the function call again. Now again, print message is called with new message, another call to print message function. It will take this string to the function definition and print this message again. Then it will come back and go to the next function call, the third one. Print message, hello, welcome to Python programming. And now third time, it will take this as an argument and print the same message. And now you can see in the output, all these three statements are printed. By function call, control goes to the function definition and it is returned back to the same line, and then it moves to the next statement under it. So this is how functions execute. Fine. Now we'll study types of arguments. This function that we have studied over here, it contains only one argument. As it is mentioned over here, it contains only one argument, str. But we can pass any number of arguments or no arguments in a function. Therefore, there are various types of function definition which we will study in the following section. Types of function arguments or parameters. Functions, first one is functions with no arguments. That means the function definition or function call will not contain any of the arguments. Second is functions with required arguments. Third is variable arguments, function with keyword based arguments, and function with default arguments. So these types somewhat are similar to C or C++, and some new are also added in Python. So we'll discuss each of them in detail. They are very important as they were important in object-oriented programming like C++, Java also. So in order to understand object-oriented programming, you need to know how to create functions. So this topic is very important and you need to understand it thoroughly. So let's move. Functions with no arguments. Unlike C, C++, Python user-defined functions can be defined without specifying argument list. So let's see how it works. This is an example. You can see here, we have created a function print message where def is a keyword. That means this is a function definition. Print message and then colon. This function prints the message print hello, welcome to Python programming, and then return. So this is function definition. And in the function call, We have just written the message print message. So you can see that there is no argument passed. The function, after arriving of function call, the control goes to the function definition and it will simply print the message, hello, welcome to Python programming. So this is the simplest form of a function. Fine. Where function is having no argument. It is vacant or void. We can also refer to it as void. But no need to write void here as we write in C or C++. Just keep the parenthesis vacant. There is another example. We are going to compute sum of two numbers. See, we have created a function def sum. This function computes sum of two numbers. This is merely a comment and called as docstring. We have created two variables, a is 10 and b is 20. And then here we are creating the, we are computing the sum. Format a plus b. Here it will compute the sum and put the result in 0 subscript. This is format which I have already told you how to format the output by using this way. And then return. And in the function call, we have just write sum. So on arriving of function call, control will go here and will compute sum of two numbers and return the result. It will come here and the program will be over. So this is also without any argument. You can see that no argument is passed over here. Next is, this is the output, sum is equal to 30 will be displayed. Next is functions with required arguments. That means we are going to pass arguments to the function. We have created a function sum with two arguments a and b. This function computes sum of two numbers and here we will compute the sum. Here we have skipped the assignment part which we have done in the previous example. It will directly compute sum of a and b and then return. And in the function call, we have passed two arguments 10 and 20. So the value of 20 will be assigned to a and the value of 10 will be assigned to a and value 20 will be assigned to b. Then 10 plus 20 will be 30 and the result will be displayed as sum is equal to 30. And then the control will come back to the function call. So this is very important type where function arguments are passed to the function definition. Fine. You can also take input from the user and then pass the arguments over here. By the input function, you can take arguments in the form of variables and then you can pass the values over here. This is very important type of functions. Next is there is another example where we are going to return the result or answer. Here we have defined sum AB and then we are just going to add them a plus b and returning the result. So in the function call, what we are doing, sum 10 comma 20. It will go to the function definition with the value a 10 b 20. It will compute the sum, return 30 and it will be returned over here. 30 will be returned over here and it will be assigned to s. S is equal to 30. Whenever we are going to return the result, then we need to assign the function call to some variable so that there must be some variable which can hold the value of the result. Therefore, that's why we have declared a variable s is equal to sum 10 comma 20. So s will be 30 now and now we will display it sum is equal to 0 dot format s. So the value of s will be inserted here and the result will be displayed as sum is equal to 30. So this is also important type where we are returning result back to the function call. Fine. Next type is no required argument list. If user does not supply the argument value where argument is desired, then the Python interpreter generates an error message. Such kind of error we also see in C, C++ also. like type mismatch error or no argument error, such kind of errors. Because in this program, in the definition, we have mentioned two arguments A and B, but in function call, we are not passing any of the arguments. Therefore, it will generate an error. You can see here, missing two required positional arguments. You can see over here, missing two required positional arguments A and B, because we have not passed any argument to the function definition. So while defining arguments, then we need to pass it in the function call also. It is very important to remember.